Hello everyone. Hey guys. Now today we are going to start with a very new topic for you, that is GOC. This must be the very first chapter from the organic chemistry that you guys should pick while studying for the organic chemistry section. I will start from very basics. As you know what is organic chemistry, there we learn about the compounds of carbon containing compounds. So the very first I would like to make you understand the hybridization of ethane, ethene and ethyne. These are the very simplest molecules of carbon. Ethane having a single covalent bond, ethene is having a double covalent bond, and ethyne is having a triple covalent bond. So how these single, double or triple covalent bond affects their nature, and because of that, because of their hybridization, because of the distribution of the S and P character in these molecules, how their electronegativity difference comes, okay, how the carbon gets difference in their electronegativity, how it affects the bond angle, how it affects the bond strength or bond order. I will be talking about on all these points, okay. So guys, let's begin with it. So the very first molecule that we are taking here is ethane. I hope you already know what is ethane. Ethane is simply, we can say that this is C2H6. If I want to draw the structure for the C2H6, I can say that here I am having 2 carbons and the 3 hydrogens are bonded like this. These are the 3 hydrogens. Okay, so this is what we already know, but how this structure came up, let's have a look. So let's talk about its hybridization. So in the ethane, we are having 2 carbon as the central atom. So 1 carbon and the another carbon, both are having the electronic configuration as 1s2, 2s2, 2p2. This is also 1s2, 2s2, 2p2. Please go through this complete session. It's very important and will definitely you people will learn something new. So here, whenever there is a point of bonding, only the last valential electrons participates in the bond formation, and in the 2 we don't have 2d, so we will not be writing any 2d, only 2s and 2p will be there. If you will be writing, it's the carbon, when the carbon is in its ground state, there are 2 electrons, that is 2s electrons. Then after we have a 2p, we have a 2p, let me rub this. Okay, 2p electrons. How many 2p electrons? We do have 2 2p electrons, 1 and 2. So again, for this carbon as well, you will be getting 2s and you will be getting 2p electrons. Okay, now further what will happen? Now guys, here the carbon remain in its ground state, will not react. Here this will first undergo in the excited state. So whenever we will be doing the excitation of electrons, so carbon will go in its excited state, okay, excited state. So ultimately when the carbon goes in the excited state, what will happen? The one of the electron will jump into this particular orbital, okay, and ultimately we will be getting 1, and when the excitation of electron will occur, there will be a jump of electron and we will be getting, this is the configuration. Now similarly for the another carbon as well, there we will be having a jump, this electron again jump into this particular orbital, that is in the first excited state. First excited state, you can write it completely, first excited state. So here we will be left with only 1 electron in the 2s orbital, and in the 2p orbital we will be having this. Now all the orbitals are degenerate, they are all having the same all the orbitals are equally filled. Now what will happen? They will try to do a bond formation, okay, they will undergo the hybridization, and the hybridization that comes out to be, that is the distribution of S and P character. We know that this is the S orbital, we know that this is the P orbital, but here these S and P orbitals will undergo hybridization and they will become sp3 hybridize. This means that now it is very difficult for you all to distinguish between all these 4 orbitals. Now they are sp3, means this orbital is also sp3, this is also sp3, this is also sp3, and this is also sp3. So we can say that every orbital is having 1/4 of s character. If you will see in the one orbital, what you can see that this is having 1/4 of s character, percentage of s character, and the p character is 3/4 of percentage of p character, 3/4 p character. He means the p character is higher than as compared to that of the s character. Okay, or in another words we can say that ki 25% we have s character and 75% we have a p character. Okay, in the terms of percentage we can say that. Similarly here also they will undergo the hybridization, and once they will undergo the hybridization, the orbitals will be of the same energy, there will be the redistribution of energies and they will become 1 2 3 4. Now ultimately what will happen, that what will you notice? Now guys, here you will notice that they are all the 1 1 1 unshared pair of electrons. So when they are all 1 1 unshared pair of electrons, they will undergo overlapping. Okay, so these are also the sp3 hybridized orbitals, and these are also the sp3 hybridized orbitals. Let me draw the structure. So now the hybrid orbitals, when there is a percentage of s character, there is a mixing of percentage of s character, and we are having 4 sp3 hybrid orbitals. So when there is a mixing, then we will be getting the hybrid orbitals. Hybrid orbitals are something like one with a bigger lobe and the another with a smaller lobe. Okay, so this is the identification of the hybrid orbital you must have studied in the chapter chemical bonding. It's a hybrid orbital. So the part, let's say this is my s orbital and this is the p orbital. So when there we will be having the s and p mixing. So whenever we will be having the s and p mixing, one of the orbital that undergoes in the overlap will become more fatty, and the orbital which does not participate in the overlap will become smaller. Okay, so this is going to be the major lobe and this is going to be the minor lobe. Why is this so happen? So when they get overlap over the z axis, then what will happen? Here this orbital will get overlap with this. So ultimately this orbital will get more fatty, this will get more fatty, this will get less fatty. Okay, so ultimately we will be getting such kind of hybrid orbital. So now here we can say that we got the hybrid orbitals. We have 4 hybrid orbitals. So one of the hybrid orbital is this, another hybrid orbital is this, the third hybrid orbital is this, the fourth hybrid orbital is this, and they are all same in size and everything, shape. Okay, I might, when I have drawn, there might be a possibility that there is a difference in shape, but no, they are all going to be the same size and same shape, everything is going to be the same. Okay, so these are the hybrid orbitals. Now similarly, another carbon also we have, and over this carbon as well we will also be having such kind of hybrid orbitals. So let me draw it with another kind of green color. If you would see, this is one of the hybrid orbital, this is the another, I just bring it a bit more closer so that I could make a overlap. Okay, so means that you will be getting one hybrid orbital, the another hybrid orbital, the another hybrid orbital, and the another hybrid orbital. So these are again the 4 hybrid orbitals that we will be having. I think this has become so much fatty. You want to correct, you can correct. It's totally up to you. Okay, so something like that. So ultimately what we can understand is, if we are having a carbon, this is our carbon and this is our carbon. So here we are having a carbon-carbon overlap, means this sp3 orbital and this sp3 orbital are doing an overlap. So this overlap is basically a sigma overlap, this is a headed overlap. So this means that this carbon is sp3 hybridized, this carbon is also sp3 hybridized, and they are doing a carbon-carbon bond formation by this overlap, and this is the overlapping zone that we can see. Okay, so this is the sp3 hydro bond formation. Now we have another case as well. Now we do have the hydrogen atom. Now you see we have the hydrogen atom bonded there. So the hydrogen is basically having the 1s orbital. 1s orbital. Hydrogen is having the 1s orbital. 1s. So this is the hydrogen having one electron. So this will be bonded by the hydrogen, this will be bonded by the hydrogen 1s orbital, and this will also be bonded with the hydrogen 1s orbital, this will again be bonded with the 1s, this will again be bonded with the 1s, this will again be bonded with the 1s. Okay, so these are all the hydrogen atoms which will do an overlap, So ultimately what we can see this, ki here this is a sp3 bond, and this is going to be the sp3, this is going to be the sp3 and s overlap, this is the sp3 and s overlap, this is the sp3 and s overlap, sp3s overlap, sp3s overlap, sp3s overlap. So what we understand is the bonding, if you are talking about the bonding between the carbon and carbon, it is because of the overlap of sp3, both are hybrid orbitals which are participating in the overlap. But here we have a pure s orbital. Hydrogen is having a pure s orbital. The one electron of this and the another electron of this are undergoing participation. The one electron from the carbon, we know now that every orbital is having one electron. So here in the carbon we have 1 2 3 4, we have 4 electrons. So one electron is of carbon, here also one electron is of carbon, one electron is of carbon, the another one electron is here, one electron, one electron, one electron and the another electron. So this is because of the hybrid orbitals. And in the case of the hydrogen, hydrogen is also having its one electron, because we know the electronic configuration hydrogen is 1s1. So ultimately the one electron of hydrogen, one electron of hydrogen, one electron of hydrogen, hydrogen, hydrogen and hydrogen participates in such a way. So ultimately this is the orbital overlap diagram for the ethane molecule. Okay, so now let's move ahead, okay, with the ethene, and then after we will be doing a comparison between all of them. So when I'm talking about the ethene molecule, ethene, as we can see, what is ethene? Ethene is simply CH2 double bond CH2. We can also write it as this is C double bond C, and here we have the hydrogen, 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 hydrogen. So why the structure is something like that? Let's have a look, guys. The answer has been hidden in the concept of hybridization again. So okay, so when I have to talk about the hybridization, sorry, it's ethene only, right, that we were discussing. Chalo. So here in the case of ethene, we will be having two carbons, okay. So again, we will be having carbon and the another carbon that we are having. They are having the configuration which is 1s2, 2s2, 2p2. We already know, we already did. Then it is going to be 1s2, 2s2 and 2p2. Now when we will be seeing the configuration, this is 2s2 and 2p2. Okay, yeah, 2p2. So here also we will be having 2s2 and 2p2. Okay, now the question is how the overlap occurs and how there we will be having a bond formation. Okay, so what happens here? Getting my point? Let's have a look. Okay, so guys, here if we would see what will be the hybridization, this is 1s2, 2s2, 2p2. Okay, so this is the electronic configuration that we are having. Now how the overlap will occur? You know, here in the case of ethene, we do have the sp2 as the hybridization. So if we have sp2 as the hybridization, then how there we will be having an overlap of orbitals, and how we will be having what will happen? So guys, this carbon is in its ground state as of now. Of course, for the bond formation, the carbon will go in the excited state. So when this carbon will go in the excited state, we will be getting one, and we will be having the jump of electron. This electron will jump to this orbital and we will be getting this. Okay, now again here also the carbon in the excited state, we will be getting, this is 2s2 and this is 2p2. Here again there will be a jump of electron, we will be getting this. Okay, now here only there we will be having a mixing of s and p2 orbital. Yes, if you, this is the very important part that we have to focus. There is the intermixing. You know, hybridization is basically depending upon the requirement. Okay, it's not a compulsion. Hybridization is a requirement. So whichever the orbitals you required to you want to redistribute their energy, only they will undergo hybridization, rest will not. Okay, so here this s and 2p orbitals will undergo intermixing of their energies. Okay, intermixing of orbitals to redistribute their energy, this hybridization, and this is a requirement. So I just required only 3 orbitals to intermix. So this is going to be the sp2 hybridization. So ultimately we will be focusing that we are getting 3 orbitals of same energy, which is sp2. this is also sp2 and this is also sp2, and the another one is going to be the pure pz orbital. So this is the very most important concept that we need to know. And here we have 1 2 3, and this is the another pz electron, that will be different. Okay, so we have 3 hybrid orbitals and 1 pure orbital. This is a most important concept that you have to focus. Now here when they will undergo intermixing, again we will be getting 1 2 3 means 3 sp2 orbitals, 3 sp2 orbitals and 1 pz orbital. So this is your pz orbital, this is your pz orbital, this is a pure pz orbital that we will be getting. Only px and py have undergone the hybridization. Okay, so this is it. Now if you would see in the case of the sp2, we can say that here we have 1/3 of s character and we have 2/3 of p character. Ultimately, in another terms, I can say that I do have 33.33% of S character, and the P character is 66.66% of P character. So this is the percentage of P character if I would see how much S and how much P is there. Now here also I would be having 1 2 3 and 1 electron will be there. Now let us start drawing the structure of a carbon. Okay, so when I have to draw the structure for the carbon, there are the 2 carbons. We do have 3 sp2 orbitals, means only 3 sp2 orbitals. So hybrid orbitals look something like this. Just a minute, let me draw it again. Hybrid orbitals look something like this. One lobe would be there, another lobe would be there, and the another lobe would be there. So these are the 3 lobes that I will be having. Let me draw for the another carbon. Okay, so the another carbon would be this. So 1 orbital, the another orbital and the 3rd orbital. Got it? So these are the 3 orbitals, and what type of orbitals they are? These are the sp2 orbitals. Okay, sp2, these are the 3 sp2 orbitals. That has to be very clear. Now over the carbon, we just don't have the sp2 orbital, we do have one p orbital as well, that is a pz orbital. So let us draw the pz orbital. Which color I would be using for the pz orbital? Let me use this. Okay, so along with this we will also be having one pz orbital. This is going to be the one pure pz orbital. So in the pure pz orbital, the hybrid orbitals are something like this. Okay, but the pure pz orbital is completely this. So this is my pz orbital and this is the sp2 orbital. Can you see there is a difference? Okay, so the pz orbital is something like this. Now here in every orbital we will be having 1 1 1 1 electron. Every sp2 orbital is having 1 electron, 1 electron and 1 electron, and this carbon is also having, in the p orbital, this is also having 1 electron, 1 electron and 1 electron. Okay, now in the pz orbital as well we are having the electron pair present. In the pz orbital also we are having an the electron present, 1 and 1 electron. Okay, in both the cases. So basically what will happen, you please have a look that what has happened here. Okay, so if you would see, you will find that here there is an overlap of electron. So there is an overlapping, and because of this overlapping, this is a what type of overlap? This is a sp2 overlap. Okay, so I can say that here, let me use red color pen. I just want to distinguish everything. So this is an sp2 overlap which is forming a sigma bond. So this is, they are forming a sigma bond. So hybrid overlap. So hybrid overlap is very strong overlap. They form a very strong bond. Okay, so this is a sp2 overlap which is forming a sigma bond. So this is a hybrid overlap which is forming a sigma. Now here we are having the another hybrid orbitals, the another sp2 and the hydrogen. Hydrogen will be having its hydrogen will be having its 1s orbital. Hydrogen will be having its 1s orbital. Hydrogen will be having its 1s orbital. So 1 electron from hydrogen will be shared. Okay, so 1 electron from the hydrogen will be shared. So what type of overlap is this? sp2 and s overlap. sp2 and s overlap. All are sp2 and s overlap. Okay. Now what will happen, how we got this pi bond? Now guys, here if you would see, this is a green color bond, so there this p orbital and this p orbital will undergo the sidewise overlapping, and when they will undergo the sidewise overlapping, because of the sidewise overlapping, this will result into the formation of a pi bond. So that's how this pi bond, why is this pi bond? This is a p-pi multiple bond. So if someone asks you that what type of pi bond is this, this is a p-pi multiple bond, because this multiple bond is formed by the overlap of pure p orbitals. Are you getting? So here this is a sigma bond which is formed by the sp2 overlap, and this is a pi bond which is formed by the p-pi overlap, because of the overlap of the pure p orbitals. I hope you got your point. Okay, so here in short we can say that if you would see this pz and this pz, they both are forming a, what kind of bond they are forming? They are forming a pi bond, and all these are get bonded with the hydrogen, hydrogen, hydrogen. Okay, all they will be get bonded with the hydrogen. Okay, I have shown it like this. Okay, so these are the electrons are getting shared with the hydrogen, and they are getting shared all together and forming a pi bond. So this is the structure of ethene. Now let's have a same kind of look over the ethyne. Okay, so if you would see in the case of ethine, what has happened, I hope now you are able to do the question very easily, your own even. So here in the case of ethine, we call this as a C2 or H2, or I can say that this is C. We do have a triple bond formation there, and this is the hydrogen and this is the hydrogen. Okay, now let's have a clear look that how does it form. Ethyne, we have two carbons, absolutely, we have to take 1s2, 2s2, 2p2. So when you do the electronic configuration, yes, this is what this comes out to be, and the carbon is in its ground state, but then after the carbon will go in the excited state, and there we will be having a jump of electron, and when there we will be having a jump of electron, this will go like this, 1, 2 and 3. Again for the another carbon as well we will do the same thing. Yes, of course there are two carbons, so yeah, two central atoms will be there. So carbon in the ground state is having only the valential electrons participates in the bond formation. That's why I am taking only 2s and 2p. So this is 1, 2. Now the carbon when goes in the excited state, then what will happen? They will be having a jump of electron. 1. This is the way, है ना? How does this occur? Now what left? Now in this question, I told you hybridization is actually depends on the requirement. So how many orbitals will undergo the hybridization, will interchange their energies? There will be the intermixing of or redistribution of energy. Only two. Yes, only two. One S and one P. If I would see here, only the 1s and 1p will undergo the hybridization, and the rest two will remain the pure p orbitals. Here only the two orbitals will undergo the hybridization, the rest two will remain the pure p orbitals. Yes, because we have a requirement of only two orbitals. So there is an intermixing, and this is intermixing results into the formation of the sp hybridization. Now we are having these two orbitals which are identical. This is sp, this is sp. So this was initially pure s and this was initially pure p, but now there is a redistribution of character sp sp, and this is going to be the pure p, and this is also going to be the pure p. This is pure py orbital, this is pure pz orbital. Okay. Now here again we will be having two orbitals of same energies, that is sp sp, and the rest will be the py orbital, and the other will be the pz orbital. The p orbitals are of three different types now, px, py, pz. So that's how. Now we have to focus. Okay, so what is happening? Every orbital is having one electron. We can see that one electron is there, one electron is there, 1 and 1. Okay, so all these electrons are there, right? Here also we have 1, 1, 1 and 1 electron. Now we have to look forward that what we can do. Let us start drawing the structure for the carbon. Okay, So yeah, I have to take many different colors, so I make you better understand what is happening in between both the carbons. So let's have a first carbon. First carbon is having a sp or hybrid orbital. Okay, so let's talk about its percentage of character. Here we can see that the s is one half is s and the half is p. So ultimately 1 by 2 is s and 1 by 2 is p. So I can say that 50% we have s character and the 50% we do have p character. We can say that. Yes. Okay, so when we have s and p character, so let me tell you again, this will be going to be the hybrid orbital. So we will be getting the hybrid orbital as this. So there is one thing, you know, s character and p character. So you would say, ma'am, what is the difference between the sp, sp2 and sp3? What was the difference? Yeah guys, there is a difference. This is the sp hybrid orbital, and if I draw it something like this is the sp2, and if I draw something like this, then this is sp3. Yeah, there is a difference. So what is the difference? The difference is of the thickness and the length of lobe. Actually, so here we have a maximum percentage of s character. The s character is responsible for the thickness of the lobe. So here if the s character is 50%, which is the highest, so that's why this lobe is the thickest lobe. Okay, and here the s character decreases. How much it is now? Here in the case of sp2, the s character is only 33.33%. So because of this reason, the thickness decreases. As the s character decreases, the thickness decreases. You know na, s orbital is spherical, so that's why. Now here the s character is only 25%. So if the s character is only 25%, means the thickness decreases more. Okay, now you would ask me, ma'am, what happens with the p character? Now if you will look for the p character, here we have 50% p character, 50% p character. Okay, so p character tells you about the length of the lobe, tells you about the length of the lobe. You know na, p orbital is basically dumbbell shape, so it's length of the orbital. Now here we have p character as 66.66% p character. So ultimately the p character is increasing, so that's how the length is increasing. Now here you would see the p character is 75%, means 66 to 75 more increased, so the length increases more and more. Okay, so in the hybrid orbitals you will always be having one major lobe and the one minor lobe, because the orbital that undergoes the overlap becomes major means fatty, and the lobe which does not undergoes overlap becomes smaller, that is the minor lobe. Okay, so this is the difference between sp, sp2 and sp3 hybrid orbitals. Now we were on the question that what we are having over the carbon. Now over the carbon we have two sp orbitals, means I will be having one very fatty lobe. Let me draw here one very fatty. Okay, let me draw it again. Just a second. So I will be having a very fatty lobe like this with a minor lobe. Okay, I drawn something like this, and I am having two sp. So yeah, they will be arranged in such a way that their electron density remains away from each other. If you will bring them closer, if you will draw them like this and this, no, we can't do that. We have to maintain a maximum angle, because there we have the electron density, and the electrons cannot be close to each other. They have to be at a maximum distance from each other. So that's how I'm drawing them opposite, because there are only two orbitals, so they must be opposite to each other. Okay, they must be as far as they can be away from each other. Now here you can see that we do have how many p orbitals? We have py and pz. So let's say this is my p, the pure p orbital. This is your py orbital. Okay, and you can say this is your pz orbital. This is the pure p orbital. They will be having a same kind of lobe. So this is your pz orbital. Is this clear? Which is sp2. sp2, the one with fatty and major and minor lobe. The p orbital is normal dumbbell shape. Both the lobes are same. Here also both the lobes are same. Just to distinguish, I have drawn them with different colors. Now again for the another carbon, we do have another carbon as well. Now this carbon will also be having the same kind of thing, sp2, sp. So this lobe is also sp hybridized. Again we will be having one more lobe as I'm so concerned about the shapes, about the size. Yes, absolutely. Okay, so this is also sp, this is also sp, two are the hybrid orbitals. Now I will be drawing the pure py and pz orbital. So the py orbital will be something like this, this. Okay, this is the py orbital. Okay, if this requires to be erased, okay, I know this is so much now, but being a chemistry teacher I have to take care of all such things if they have a significance, meaning. Okay, and this is going to be the pz orbital. So this is pz and that was your py, this was your py. Now we have drawn the sp orbitals, we have drawn the py and the pz orbitals. Now here how many electrons we do have? They all have one electron. So here also we have one electron, here also we have one electron. Again this carbon sp orbital is also having one electron and one electron. If you talking about the py also, we have one and one electron. So in the py we have one electron, in the pz also we also have one electron and the one electron. Okay, so this is one electron we do have. Now how many carbons are undergoing bond formation? So this carbon, with this carbon only two hydrogens. So one with this, here we will be having one hydrogen with one electron forming a bond like this, one hydrogen with one electron forming a bond like this. So these are your hydrogen atoms. Okay, these are your hydrogen atoms, the s orbital of the hydrogen atom, which is a pure s orbital. So guys, this overlap is, this is having the sp orbital and the sp orbital is getting overlap with the s orbital in the case of the hydrogen, and the sp and s bond formation will occur, which is also a headed overlap. So that's why this is a sigma bond. Is this clear? Now here we have seen that the sp and sp orbital are forming a headed overlap, and so therefore this is going to be a sigma. So one of the bond is going to be the sigma. And why this is sigma? Because of the overlap between the sp and the sp. So sp or sp orbitals are undergoing the bond formation. Now the another point that we have to focus here is, bache, that is this p orbital and this p orbital. Now there is an overlap of pure pp orbital and this is a sidewise overlap. This is a sidewise overlap. This p and this p can do a sidewise overlap. Okay, so this they will, whenever we will be having a sidewise overlap, there is a weaker bond formation and which is known as pi. So one of the bond is said to be pi and this is going to be the py and py pi overlap. Okay, this is known as py pi and py pi overlap, or you can say p pi overlap, that will be also right. Now here we do have one more p orbital, that is the pz orbital, and this will undergo overlap with this. This means this and this, they will do the sidewise overlapping and will form the four overlapping zones. So ultimately this is also a pi bond, this was also a pi bond. Now this pi bond is also because of the pz pi and the pz pi overlap. So we do have two pi bonds and one is sigma bond. Okay, so the sigma bond is between the hybrid orbitals. Now guys, this is what we have understood in between the ethane, ethene and ethyne. Now I want you to do the comparative study. So now we will be doing the comparative study, and now let me tell you guys ki here what is the difference, what difference we could see in all the three structures. In the case of ethane, you know that this is your carbon, hydrogen, this is carbon. Okay, I will be telling you about the bond formation, which is bond stronger and which is weaker. Now here you do have ethene. In ethene we have this kind of hydrogen, and ethyne you do have this kind of hydrogen bonds. Okay, so now if we will compare between all of them, there we have a sp3 and sp3 overlap. Okay, so sp3 overlap, if I ask you the sp3 overlap, you know sp3 orbital having the maximum percentage of p character is going to be a longer orbital with a smaller lobe and the longer orbital with a smaller lobe. Okay, so this is my carbon and this is my carbon and this is your sp3, sp3 overlap and forming a sigma bond, and they are forming a sigma bond. they are forming a sigma bond because of this overlap. Okay, so this is what I want to tell you. So this is a overlap between the sp3 and sp3 hybridized carbon atom. Now if you would see this carbon, okay, if you would see this carbon, what you can focus is, this is the sp2, this, there we were having the sp2 overlap. So if you would see the sp2 overlap, the s character is increasing and the p character decreasing. So ultimately if I look for the lobe, this will become smaller in length and more fatty, smaller in length and more fatty. Okay, so something like this. This is your nucleus, this is your carbon, this is your carbon, and here we were having a sigma bond. Okay, so this is your sp3 overlap, sp3 overlap. This is your sp2 overlap, sp2 overlap, sp3 overlap. They are also forming a sigma bond, they are also forming a sigma bond. Okay, and now this is your sp and sp character. This means that the lobe will become more fatty and less longer, more fatty and less longer. So this is your sp and sp overlap, sp overlap. Okay, this is it, this is it. So they all are headed overlap. This is also sigma, this is also sigma, this is also sigma. So we know that we do have a sigma bond here, sigma bond here, sigma bond here, and the pi bond is because of the p pi overlap. Okay, so the pi bond is because of the p pi overlap. This is also a p pi, we do have p pi overlap, and this is also p pi overlap, forming a pi bond. Okay, so now guys, here we want to discuss with you the bond length. Okay, so if there comes the question of the bond length, then what we can do is, we can understand is, here in the case of sp3 and sp3 hybridization, because the lobes are lengthier, okay, so this carbon carbon sigma bond, this bond is longer. So if there is a question about the bond length, so we can say that the bond length in between the ethane is bigger. Okay, this is having a bigger bond length, so this bond is longer. Okay, so bond length of ethane, the bond length of ethane is greater because the nuclei and the distance between the two nuclei is going to determine the bond length. And here the two nuclei are coming little bit more closer, and here the two nuclei are coming more and more closer. So ultimately the ethane, the bond length is higher than the ethene, and then the ethyne. So ethyne is smallest in their bond length. Okay, so guys, as the bond becomes shorter, now you can see that the nucleus are holding the electrons more tightly. This nucleus is holding its electron more tightly, and this nucleus is holding its electron more tightly. So there is a bond formation. So ultimately, if there is a question about the bond strength, we can say that ethyne is much more stronger bond, because if you will see this sigma bond is very stronger. Ethyne is more stronger than the ethene, then the ethene, and then the ethane. Why this is the order? Because we can understand that as the bond becomes shorter, it becomes stronger. Okay, bond becomes shorter and stronger, So in the case of the ethyne molecule, the bond is much shorter and stronger. Now here, when we were having the sp overlap only, so there were the p orbitals which were undergoing the sideways overlapping and forming a pi bond. So if there is a question about the bond order, now what you can say about the bond order? We can say that here the bond order means the number of covalent bonds between the carbon and carbon. So we are just doing a comparative study between the carbon and carbon. So if you will see the bond order, so here the bond order is 1 only. The bond order is equals to 1. Here in the case of ethene, the bond order is equals to 2. There are 2 number of covalent bonds. Okay, so and here in the case of ethene, the number of bond order is equals to 3. So here we can say that the bond order is increasing. Bond order is increasing. So bond order increases, bond becomes shorter and stronger. Always remember, shorter the stronger. Okay, I hope you are able to write this, shorter and stronger. So I discussed with you what happened with bond length, bond strength, and bond order. Now if you would see, now you understood that we have to, whenever we were forming the sp2 orbitals, so they have to be at a maximum distance from each other. Now let's talk about the percentage of s character. Now if I talk about the percentage of s character in the case of ethane, when we were having sp3, so in the case of this is the sp3 hybridized carbon. we were having the sp3 hybridized carbon. So sp3 hybridized carbon is basically having only 25% of s character, 25% s character. Now here what is happening, the percentage of s character is 33.33% s character. Now here the percentage of s character is how much, that is sp 50% s character. So the s character is basically, the percentage of s character is basically increasing. So if the percentage of s character increases, what happens, you know guys, s character increases, the electronegativity increases, the electronegativity increases, the electronegativity increases. So if you ask me, they all are carbons. A carbon usually have an electronegativity of 2.5. So will the electronegativity will remain same? No. So as the s character increases, the electronegativity increases. Always remember this, I have also discussed with you in the chapter electronegativity, which I have taken it before. S character increases, electronegativity increases. Okay. So here this carbon, the carbon which is an sp3 hybridized carbon is less electronegative, and here the electronegativity is increasing. Okay. So this is having less electronegative, more electronegative and more electronegative. So as the percentage of s character increases, the electronegativity increases, and there is one more point, that is the bond angle also increases. So what relationship you need to remember, the percentage of s character is directly proportional to electronegativity, is directly proportional to bond angle, bond angle, please make sure. So as the s character increases, the electronegativity increases, the bond angle increases. We can see this experimentally here. The bond angle, in the case of the bond angle, in the case of ethane, we were having 109 degree something. Okay, but here what has happened, here the bond angle become 120 degree, and here what is the bond angle, the bond angle become 180 degree. So all these answers can be answered only by the concept of hybridization. Okay, so guys, electronegativity. Okay, so I won't talk about the electronegativity values. Usually a carbon has an electronegativity, usually a carbon which is sp3 hybridized is basically having an electronegativity of 2.5, 2.5 a tetrahedral structure. Here we have a trigonal planar structure, here we have a linear structure, right? So here we can say that the bond angle is increasing, this is 120 degree, this is 180 degree, okay, and now here we can say that this is a simple carbon which is having the electronegativity values as per the Pauling's principle, this is 2.5, but later on the electronegativity increases. Okay, so electronegativity increases. Now it's a very good question that usually come in the paper. So that if the electronegativity increases, why the ethyne are most acidic? The question is why the ethynes are most acidic. So your answer is why this hydrogen is most acidic, because this carbon is highly electronegative. So because this carbon is highly electronegative, so that's how this gives you triple bond C negative, triple bond C negative plus H positive, and this negative charge is very stable. This conjugate base is very stable. Okay, so that's the reason why the ethyne is having the highly acidic hydrogen atom, because as the hybridization becomes sp, as the percentage of s character increases, the electronegativity increases. So remember this golden rule, if this increases and this increases. Okay, so guys, I hope you find this session really helpful. If is it so, then please, thank you so much. Please like, subscribe and share if this session helps you anyway. Do let us know from your comments, either a positive or negative feedback. We just want a genuine response from you all, guys. Do follow me on an academy, because over an academy I have taken a lot number of courses for you. As you can see that here are 127,000 students. This is K, means 1000, means 1 million plus students are already learned from my courses. Okay, and I'm talking about the followers of an academy, which is only an educational platform, and only the IITJEE students have followed my courses. Okay, so guys, you can have a look. So there are 6,000 plus dedications. So if you really want to learn from me and learn through an academy, you do follow me on an academy with this box. Just go over the link, and you can just simply search over the Google Megha Khandelwal an academy. You will find my page over an academy. Do follow me there. You will be able to see all the free content available there, all the special classes, and if you are really interested interested in any of the subscription, then you can also use Meghamam as a referral code. I would be happy to help you. I would be happy to guide you for your JEE preparation. Yes guys, you can connect with me and I will be discussing and helping you with all the guidance that you require for your examination. So this is my code Meghamam, by which you can subscribe on Unacademy. This is it for today. We'll come up with one more session with more number of sessions on GOC, and I will make sure that this topic you are going to rock. Okay, so this is my promise to all of you. Bye bye guys, see you, have a great day.